So this video is just a prelude to the shaft preliminary design example question. Right, so this example goes through all the topics that were covered in shafts over the past few weeks. So what we have is a proposed design of a shaft to carry intermediate gears for a drivetrain. 200 horsepower is transmitted through the shaft at 600 RPM. So we have the horsepower, we have the RPM, we can calculate our torque the shaft will be transmitting. Power enters through the shaft at gear A. So it enters through here and delivers the power to gear Q from gear C. So it goes through A, goes through the shaft and comes out at gear C. We have the material with our material properties 572 megapascals, 813 megapascals as the sigma ultimate, and we have the pressure angle for the gears. The pressure angle for the gears will be used to calculate the forces acting on the shaft due to the meshing of the gears. The axis now to determine the minimum diameters for the proposed shaft layout in figure 2. Right, so before we go into figure 2, let us look at what we have here. We have a shaft. This is just a rough schematic. We have the gears at points A and C, and at B and D, these are the bearings. So these will be the bearings that will be supporting the shaft. Okay, so if we look at the shaft from the viewpoint of A, this is what we have. We have the gear P, which is input to the shaft. It would actually rotate gear A, and as the shaft is rotating, gear C now rotates gear Q, which is the output. This here is the proposed layout mentioned in the question. So the proposed layout is one such that we have step or shoulders on the shaft. So this is called a step shaft. And the steps in the shaft or the shoulders are used to hold the components in place or to locate the components. So for example, we have a shoulder over here, the gear would go in, and then we will put a retaining ring or a circle on that end. So that's an example of why we would like to use a step shaft. Now the question is determining minimum diameters for the proposed layout. So at every portion here, we want to determine that minimum diameter. Right, so if we come back and look at the gears, so to do this, we will be required to calculate the forces from the gears. Right, and this was done in the spur gear section of the shaft design notes. So if we look at the first gear, gear P drives gear A. You can see the input is in that direction, and it rotates on gear A, so there will be a force acting down on the shaft, like that. So this will be WTA, is the tangential force at point A. Similarly, if we look at Q, and we look at the tangential force, so gear C now is what is driving gear Q. Right, so they will have a tangential force on gear Q, which will be up on gear Q, but we're concerned about the shaft on which gear C is on. So the equal and opposite will be acting down here. So this will be WT at position C. Now also we discussed in the spur gear section that the radial load from the gears act in a sense to separate the gears. So we will have a separation force like this, trying to separate the gears, and that is the radial load. So that force will be acting in this direction here. So this is WR for radial at position A. Similarly, again trying to separate the gears between C and Q, so this is WRC. So these will be our forces, our applied forces. Okay, so if you were to look at the PDF, which was shaft example basic workflow, that PDF that was uploaded, it will actually go through for a simple shaft with a single gear in it, how to actually calculate those WT and WR forces, and also it speaks to how the shaft will have or could be modeled as a beam but in two planes. And what I mean by that is if you look at the shaft, from a three-dimensional perspective, we have WTA, WTC, and we also have our radial forces. So we could look at the shaft from on top, and then we could look at the shaft from the front. Right, so that PDF that was uploaded will actually go through and look at that and give us an indication as to how we could go about now doing our shear force and bending moment. So at that point, the shaft will not be treated as a beam. The next thing the question asks for is to determine what is the appropriate bearing. Right, so they give us an operating life of 9,000 hours and access to calculate the bearings. So before doing this, you would have to go through the video for bearing selection. That was the lecture that we did not have due to the assignment, or sorry, the project. So we would have that video lecture will actually go through in detail how to select a bearing, and there's an example in there. Actually, exactly how that example was done, we'll be doing it in this case here. And finally, they will ask us to determine the length of the keys. Right, so the keys are these positive drive elements that are located for gear A and gear C. Now there's no key here. This was an error in the print of the book. Right, the bearings do not need keys. So there's a key for gear A and key for gear C. So what is the dimension of these keys? So we'll actually go through that at the end as to determining those key lengths and the key sizes. So the quiz that you have in front of you now is not for any marks or weighted or anything. I was just trying to use the quiz feature in Canvas so that they could go from point to point or topic to topic as we go along. So you'll be asked to, for example, calculate the torque. So you calculate the torque and then you move on to the next section. So as you move on to the next section, the answers for the previous question will be given. Right, so it's important that you go through each step and actually work it out on your own. And as you move on to the next question, well, then you will see the result, and you would know if you're correct or not. And actually, there are some guidance as to how you could go about what formulas to apply, where to look for information. So the quiz is meant to go back and forth continuously, go through each question. If you were to click submit, well, again, it will not be for any marks. But if you click submit, you will actually get some feedback for the individual questions. But the feedback is the same that is in the beginning of each question. Okay, so I urge you to go through this quiz. And again, if you have any questions, you could send me a message on Canvas.